All right, so what we're going to do today is we're going to review something you learned last year, which is finding empirical formula and molecular formula. It's actually pretty simple, basic chemistry calculation, but I want to highlight the steps so you don't forget, and it makes it easy for you to review this. There are 4 steps in finding the empirical formula. The first step is when you're given a problem, you're going to just change percent to grams. So that's the first step that you're going to do. So if you're given a problem, a typical empirical formula problem looks like this. They tell you that you have 29%, 29.4% calcium, 23.5% sulfur, 47% oxygen. What this step means is you're just going to write it as grams because we assume it's 100 grams, so the percentages convert directly into grams. So then what I'm going to do is I'm going to put the 29.4 grams of calcium goes here, 23.5 grams of sulfur goes there, and 47.1 grams of oxygen. So all I do is just change the percent, scratch out the sign, change it to grams. That's the first step. Second step is you convert grams to moles. Remember using a grid, using molar mass, because we do this based on elements. Always elements, you're going to look up the value from the periodic table. So for example, calcium, if you look it up, you would find it's 40 grams per mole. Sulfur is 32.06. This is rounded a little bit too much. Remember, you want to have 2 decimal places, and oxygen is 16.00 listed on there. So that's the second step, is you're going to convert grams to moles by dividing by the molar mass. And what you see is you end up with different numbers of moles, 0.735 moles, 0.735 moles, and 2.94 moles. So all you're going to do is convert grams to moles. Just dividing by molar mass is all you're really doing. Then the next key step is you're going to divide all the moles of all the elements that you just calculated by the smallest number of moles. Whichever the ones in your calculation is the smallest number of moles. So if we look here, I have 0.735, 0.735, and 2.94. The smallest number of moles that I have is 0.735. So I'm going to divide that into all the numbers. I'm going to divide that into all the numbers. I'm going to divide it into 7.35, 0.735 into 0.735 is going to be 1. You're going to divide it into this one, you're going to get 1. And then 2.94 divided by 0.735 is equal to 4. In the end, you always want to do it in the order you list the moles and the formula in order that the elements are always given. So in this case, calcium comes first. That means I have Ca, subscript 1 based on my calculations, which are right, it should be right up here. When I divide by the value. The next one is sulfur. If I look, sulfur is 0.735 divided by 0.735. That's going to be 1, so I put an S. And then finally, 4 oxygens, calcium sulfate. I found the empirical formula. The definition of an empirical formula is the lowest whole number ratio of elements in an ionic compound. That's what an empirical formula is. So we find them in ionic compounds. Very simple steps. Last step is only required if you're left over with a non-whole number. So if you are within less than 0.1 of a whole number, like 4, 3, or 2, you can round it. You're allowed to round. If not, we use what we call decimal magic, or I call decimal magic. What that means is you take a whole number to take the decimal out. So if you ended up left over with 0.5, you would multiply by 2. All the values have to be multiplied by 2. If you ended up with 0.33 or 0.66, you have to multiply by 3. If you end up with 0.25 left over after you divide by the smallest number of moles, you would multiply by 4. And then sometimes you might get one that's a little bit more requires a larger number than that, but it's pretty rare. So that is how we find an empirical formula. To review, you change percent to grams simply by writing it. Convert grams to moles by using a grid, dividing by the molar mass of whatever your unknown element is. You plug it in from the periodic table, you get moles. Then you divide by the smallest number of moles, and then check to make sure. You can only round if it's less than 1/10 away. Otherwise, you have to use a whole number to take them out. Next type of formula you have to figure out is very similar process. Actually, it's an add-on to the process we just reviewed. Step number 1, if you notice, to find a molecular formula, and the definition of a molecular formula is the actual formula of how a compound exists in nature. So it's the actual formula of how a compound exists in nature. So the first step to finding a molecular formula is to find the empirical formula. Okay? Some problems are a little simpler. They will actually give you the empirical formula before you start. So then you can start at step number 2 and then just do step 3 and 4. So sometimes you'll start with the percents and have to find empirical formula, then go through and do the rest of this. Some of them you'll be given the empirical formula, so then you go right to the second step, which is calculate empirical formula molar mass. Then the third step is you take the actual molar mass, which is always going to be given to you in the problem. So that's given to you in the problem. You put that on top. The empirical formula molar mass is what you calculated. Number 2 goes on the bottom. When you divide the two numbers, you will always get a whole number. That number is what you're going to multiply the subscripts with to get the final answer. Bam, you're done. Bam. So let's take a look. Here's my problem. NutraSweet. They give me a percentage of carbon, percentage of hydrogen, percentage of nitrogen, percentage of oxygen. Calculate the empirical formula first. Then you have to find the molecular formula second. And notice, alert, they gave me the actual molar mass. The actual molar mass is 294.30. Well, first step. First step in the empirical formula is I change percent to grams, which means I'm going to have, when I go to do this, I'm going to have 57.14 grams of carbon right there, 6.16 grams of hydrogen, 9.52 grams of nitrogen, and 27.18 grams of oxygen. All I'm going to do in a grid is divide by the molar mass from the periodic table. That's all you're really doing. Hydrogen is going to be 1.01 grams of hydrogen is equal to 1 mole. It's always done by elements. Nitrogen is going to be 14.00 grams of nitrogen per 1 mole of nitrogen. And then finally, oxygen is going to be 16.00 is equal to 1 mole of oxygen. So you're going to do those calculations. Here's an example of what happens when you do it. Calculate it out. I get 4.76 moles of carbon, 6.10 moles of hydrogen, 0.68 moles of nitrogen, and then 1.7 moles of oxygen. If I look at it, I have to, the next step in the empirical formula, I just did 1 and 2, is divide by the smallest number of moles. So if I go back here, the smallest number of moles is going to be 0.68. So I have to take each of these and divide them by 0.68. 0.68 there, 0.68 there. That's my next step. So I divide by the smallest number of moles. When I do that, I end up getting this. I divide all these by 0.68, so I'm right here right now. All these are divided by 0.68. I end up with 7. 8.97, which is within a tenth, so that's technically 9. 0.68 divided by 0.6 is 1, and then bam, 2.5. I cannot round because it's larger than a tenth. If you remember the rules when I introduced this to you, the rule is you can only round if you're within a tenth of a whole number. So then we have to use decimal magic. If you come down here, I have a 0.5, which means then I have to take the, if I have 0.5, I multiply by 2 to take them out, take the decimal out. So what does that mean? Well, it means I have to take this and multiply it by 2. You have to multiply everything by 2. So 7 times 2 is going to be 14 now. 9 times 2 is going to be 18. 2 times 1 is going to be 2. 2.5 times 2 is going to be 5. So that means my empirical formula is going to be C14, H18, and N2O5. That is my empirical formula. That's part 1 of the problem. I solved for the empirical formula. But remember, in the original problem, they also asked me to find the molecular formula. So then I got to go back and look at the steps for a molecular formula. First, find the empirical formula. Check. Did that. Second thing is I have to calculate the empirical formula molar mass. So if I look, where am I here? I have to actually calculate out using the periodic table. You can do this on your calculator right now. You can actually hit pause and do it on your calculator. You should try it. Carbon, 14 times 12. Hydrogen, 18 times 1.01. nitrogen 214, 2 times 14, 5 times 16 for oxygen, get you a molar mass, empirical formula mass of 294 grams per mole. That's what you get. If you look, the next step is to divide the actual molar mass from the problem by the empirical formula molar mass. In this case, we said the empirical formula molar mass we figured out was 294. If we go back to the original problem, the actual molar mass is 294. So if I go back to the original problem, it's 294. So then that means I'm basically dividing 294 by 294. This number always has to come out to be a whole number. In this case, 294 divided by 294 is going to be 1. So then I would take this number back, except it's 1, so it's easy. Normally I would take that number and go and multiply all the subscripts of the empirical formula by this number, and I get the molecular formula. This just happens to be a case where it happens to be the same, empirical and molecular formula. So that's what you have to do to review. Remember, empirical formula is always in lowest whole number ratio, percent to grams, convert grams to moles, simple conversion. Divide by the smallest number of moles and check to see if you can round. If not, bust out decimal magic. That's how we do empirical. Next one, how to find a molecular formula. Molecular formula, you find the empirical formula, or it could be given to you. If they give it to you, it makes it even easier. You calculate the empirical formula molar mass. You pop it into this formula right there, top and bottom. And then when you get the number, you multiply the subscripts from the empirical formula, and you are done. All right? So tomorrow in class, you're going to need to do some of these calculations. You don't have any for homework, but this is prep for tomorrow for class. Hope you have a nice evening, and I will see you on Tuesday.